it's important to be mindful of what we're trying to achieve and to hold us to that standard. So in the NDN project, we really do believe that NDN is an example of a new kind of protocol that is general purpose, but does enable some important characteristics. We think that with NDN, communications really can be more secure in qualitative and quantifiable ways. We think that the underlying infrastructure that forms our digital communications infrastructure can be utilized far more efficiently. We think that life can be made simpler for application developers and that new things are possible. So those four elements are really how our work should be judged. And I hope we as a research community and everyone watching our progress will measure us by those four characteristics.
How exactly you design a forwarding strategy to suit your application scenario and application needs, that's a big research question. And also, because of you have forwarding strategy, so your routing protocol may be designed differently. Some routing scheme doesn't work well in IP, but might work well in NDN. So I think it is just we haven't really fully grasped how to take advantage of all these possibilities. That's to me, that's the biggest question.
So I think there's two really big open problems left in NDN. So in particular, we have the trust model stuff. Now, a lot of that isn't new. These are the same trust problems we've been dealing with for the last however many years. The thing is, though, we've made this a key part of the architecture. And so consequently, it is something that's being brought to the forefront. This is something that you need your mother to be able to use. And so if you don't have something that's nice, easy to use, and makes sense for applications, then it's just a complete no-go. Another part, I'd like to touch back on forwarding strategy. In forwarding strategy, because it's such an integral piece and we have all these different things going on at different nodes for different prefixes, we need to really understand how forwarding strategies can interact as well as with the applications.
I'm interested in the ability for NDN to solve the broken link problem. You know, you see something interesting, a newspaper article or a scientific paper, you put a bookmark to it, and then 5 years later, it's gone. My interest is in ways that NDN can help solve that problem. And the open research question is, since NDN supports locationless data, it's likely that 5 years after a graduate student writes an interesting paper, they're not supporting that data anymore on their own computer at their lab because they've moved on. So how can NDN find that data later on and make sure it's still valid?
There are a number of really thorny research problems, and some of them relate to inherently difficult problems when you switch paradigms, and others are research that is based on thinking in the architecture that we have something better, but not really being able to have the design completed well enough to exploit it. So let me give you one example of each. So routing in the IP world was a hard problem when people designed the first generation, even the second generation of routing protocols. And now we're relatively confident that within that paradigm, it scales okay. We have 10 to the 9th endpoints, and our global routing system seems to work okay. The problem, of course, is that if you switch to an architecture where you're routing directly on content and hosts, the count of the number of objects you need to route to is now 4 orders of magnitude greater. And one of the things IP wrote very well was Moore's Law, which got us two orders of magnitude from the time IP was first created. Well, Moore's Law might get us another 1 to 2 orders of magnitude in our lifetimes, but it's not going to get us 4. So for routing, we really need to step back and figure out if there is a feasible routing system for this kind of architecture, or whether we need to sort of step back and say, well, that was a nice idea, maybe it'll work in restricted circumstances, but we need some other thing in the architecture like a naming service or a level of indirection or something that people haven't yet thought of. So that's an example of the sort of the first category of hard problems we don't really know a solution for. Second category is in the IP where we've kind of reached the end of the road in the opportunities to improve congestion control. The fundamental work that it's based on was done back in 1988 by Van Jacobson, Sally Floyd, and some others. There's actually some earlier work, but that tends to be marked as the beginning of really understanding congestion control in IP. And it's not going to get a lot better. We're doing about as well as we can, which is pretty good, but not really that well, because in IP we have end-to-end congestion control and very little opportunity to do anything on a more fine-grained basis. So with ICN, again, since we have hop-by-hop state, there's the opportunity to employ hop-by-hop congestion control in a relatively powerful way in order to improve the performance of our congestion control algorithms. The second thing, which provides, I think, a true opportunity, is to get away from the flow-based congestion control model of IP, which works well for single flows, but we've learned in things like the web where people fire off 50 simultaneous TCP connections, they can gain the congestion control of the system just by adding connections. In an ICN architecture like NDN, where we have multi-destination, multi-path forwarding, we can shift away from congestion control algorithms that work on a flow basis to just connect to congestion control algorithms that work on an individual content or equivalence class of content basis. And while we don't have really well-developed answers to this yet, it has in fact started a whole new generation of research work in alternative approaches to congestion control that take these kinds of factors into account, couple the congestion control to the routing in a way that hasn't been possible in IP, and also couple the congestion control to caching. So I see pretty big opportunities there for the research agenda in NDN and other ICN architectures.